All right, so we decided to explore capture the flag competitions, also known as CTFs, because we have experience in these through the cybersecurity organization called SIGPOTI. So specifically, a CTF competition, capture the flag, is where teams are presented an array of challenges in different categories, Jeopardy style, where there's point values associated with their increasing difficulty. So specifically, it might be presented like somewhere on the order of like 5 to 10 challenges in each category, where point values may vary somewhere from around like 100 to 500 depending on their difficulty. The harder ones maybe somewhere between like five or maybe down to zero teams would solve, and the easier ones maybe most of the teams at the competition would solve. So specifically, we were interested in seeing how team strategy and selecting challenges, as in like how well they spent or allocate their time, and how teams hoarding their points or hoarding their solutions until the end can affect the ranking. So specifically, like flag hoarding is where teams, in order to try to deceive other teams into thinking they have a larger lead than they do, will withhold their solutions until the end of the competition to kind of surprise other teams.
So we a little bit more about the model. We do make a couple assumptions in our model for the CTF competition. So each team has a single solver for each category, and then these challenges have specific points assigned to them. And we do have three different categories for challenges that are modeled based on real CTF competitions. There is also a finite set of challenges available in our model, and there is a time that the time that a team needs to take to solve a challenge is given by this specific formula on the side, which is the difficulty divided by strength. And there is a very specific duration for the competition, which we'll see in the next slide. And there's also a chance of failure that the team is not able to solve a specific challenge, and then they must do something else. So moving on, here's a CTF competition layout. So this is kind of the event graph that we're modeling the system from. So we have the initialization, and then we have the observation stage. And then for all teams that are going in all categories to anything, they would select a challenge. And when they select the challenge, they can either select it randomly, or we have a smart select algorithm that Jake talks about a little bit more in a future slide. But a team basically solves the specific challenge that they select, and then they finish that challenge. And then if there are specific challenges left for the team in that specific category, they need to go back into the select stage and solve them. And then once they're done solving everything, they're in the finish stage. And a team can decide anytime that they want to hoard, which is basically just not revealing their points on the public leaderboard or public scoreboard. And that's also a state that the team can go in for any given challenge. Moving on, we have a couple events in our system. So we have the initialization. This is just before the competition. Then we have the select, where they want to select a new challenge to work on, either random or smart, as I went over in the previous slide. And then we also have the finish, so they've successfully finished solving the problem. And then they want to, unless they want to be hoarding, in which case the points are not shown yet on the public leaderboard. And then we have the specific hoarding decision slide. So at that specific time in our code, the top team may decide to hoard any points that they've kind of you know cumulatively earned. And then we have the observation and the completion stage. And so after the whole competition's duration is up, the final rankings are determined, points are tallied up, and the hoarded points are shown to the public. And so these are kind of the events in our system. Now, talking a little bit more about the verification and validation in our model. So for validation specifically, we have historical CTF data. We built into CTF events nearby with our university RSOs, etc. And so stuff like the UMass CTF, SIGPONI CTF, as well as LA CTF, there are published data of the scoreboards, and we have so on the bottom left, as you can see, is the official UMass CTF scoreboard from this year, and then we can see on the right is our model's results. So it's pretty much we've like validated that our model is a good representation of that. And then for verification, we use NumPy for any like RNG or any calculations. So we know that that kind of ensures correctness with our Python code. And yeah, that's kind of how we've implemented that. So moving on to results.
So now to move on to results. The first result that we were interested in was the team's challenge selection strategy. So for this, we included two strategies. One where you'll randomly select a challenge, and the other where you'll select a challenge which is most beneficial to you based on the number of points that it would grant and the difficulty in doing so, and also factoring in your team's specific strength of that challenge. So in reality, these parameters don't truly exist. So it's sort of approximating your estimation of these, which may be somewhat inaccurate, but you generally have a pretty good idea, in my experience, of your strengths and how those will play out in the various challenges. So random selection plays out quite poorly here, with around 1850 points earned in our one team simulation. Specifically, this simulation has a fixed set of challenges and one team trying to solve them, as we're only interested in the points earning, not the rankings here. And you can see that random performs quite poorly because you might pick a challenge which has a very high difficulty that you aren't well equipped to handle, and you'll waste a lot of time on that. So this sort of emphasizes the importance of spending your time well in a CTF and not having your best solvers waste time on challenges that they're not well equipped to handle. So this also justifies the practice that we often see where teams start off very quickly accumulating points by solving the easiest challenges first, and then slowly working towards the more difficult challenges as the event progresses, which we often see in scoreboards such as the one on the previous slide. So specifically, we see that because we chose a large number of trials, specifically 10,000, we have pretty good estimates of these means, where the variance is quite low, and we have 95% confidence intervals that are extremely narrow. So we can be very certain that these selection strategies have the impact that we've measured here. Now on to our next results, which is the initial and final rank. So, the rank seen 3 hours before event close compared to the rank seen at event close. Our first table is of 1,000 trials and no hoarding employed by any team. We'll see that ranking is quite stable, as you might expect. So the lead team will tend to maintain their lead. The other teams tend to maintain their position, where the middle of the leaderboard gets a little more fuzzy. And this is pretty much expected. We declined to do any further statistical analysis because if we had like a 5x5, or maybe if we'd run a larger trial, even larger table, confidence interval matrix like this would not be particularly useful to interpret, because there'd just be a lot of noise. Basically, there'd be so much to look at. So we decided to just keep it kind of more of like a qualitative analysis here. And we see, though, in our second table with flag hoarding, there's much larger variance in score, where a team specifically that was looking around rank 4 near the end of the competition will shoot up to the top rank, as they were probably hoarding flags at that point. So we can see that if a team employs flag hoarding, they could really deceive other competitors in their leaderboard ranking as like a team that might be much lower down, maybe rank 4 or even lower if there were many more teams involved, could rapidly increase at the end of the competition. So to conclude, teams need to be very careful in where they spend their time. As we saw in our strategy selection, it can make a very big difference if you've wasted a bunch of time on a challenge that you failed to solve, or that just has lower point value than it's really worth to spend all that time solving. So you probably want to start with the easier ones that have a good amount of points to start. And teams can't rely on the scoreboard to judge their lead and relax their play, because as the competition progresses, the scoreboard may change rapidly for various reasons, but especially due to hoarding. So don't relax your play if you think that it's easy for some reason.